So let me explain once again. What is the light? Please tell. The light is the form of energy in the form of electromagnetic wave. It propagate in the medium. When it hit our eyes, it produce the sensation. What is the electromagnetic wave? You tell. The electromagnetic wave is nothing but in the form of electric field, right? Suppose this is the electric field, right? And perpendicular to this, the magnetic field is there. And we will discuss this electromagnetic wave also, right? Suppose this is the electric field vector, this is the magnetic field vector, right? In the x direction, y direction, and in the z direction is the direction of the propagation, right? Explain, I will tell you, right? The dual light has the dual nature. It means it can behave as the particle nature as well as the wave nature. On the basis of the particle nature, we can explain the photoelectric effect in the modern physics and the Compton effect also, right? On the basis of the wave nature, we will explain the reflection, refraction, interference, diffraction, and polarization also, right? So in this chapter, in the wave optics, we will use the property of the light as a wave nature, right? And we will importantly explain the interference in the form of Young double slit experiment, right? Copy this. So now we will discuss the Huygens principle. Huygens principle, Huygens wave theory of light. Huygens wave theory of light. As I told you, the light has the dual nature, right? The wave as well as particle, right? So listen one thing, although at this time the Huygens principle, right, was discovered during the time of the Newtons. There was the two scientists, the Newtons and the Huygens, right? Huygens. So there were the two scientists according to the Newtons, right? Newton told that light is the wave, light is particle, right? Light propagate in the form of particle. But at that time, Huygen was also the scientist who told that light is wave. Do you understand or not? Light is particle according to Newton, light is wave according to Huygens. Is it clear or not? But at that time, the Newton was the great scientist, but Huygens was not so, right? So therefore, the scientists at that time, they assumed the light is the particle, right? He gave his corpuscles theory of the light, but later it was rejected after, right, few years, right? And Huygens gave the theory at that time, right, in the form of wave theory of light, right? That he told that light propagate in the medium in the form of the wave. But at that time, Huygens theory was rejected. You understand or not? It was approximately in 16th century, right? 1600 years, right? But in 1801, the Young was the scientist who performed some experiment on the light, right? And according to him, the light is not as to be particle. This Young double slit experiment can be explained on the basis of the Huygens principle, right, or Huygens wave theory. The Young double slit experiment was performed. Is it clear or not? So after that, the scientist assume that light is what? Light is wave. Are you getting or not? It was 1801, right? But in 1905, right, Einstein was the scientist. Einstein told that the light is nothing but the particle again, right? On the basis of the particle nature of the light, he explained what? Photoelectric effect, right? He explained the photoelectric effect. Einstein explained the photoelectric effect on the particle nature of light with the help of quantum theory, right? Max Planck quantum theory. Max Planck quantum theory. Is it clear or not? Initially, Newton was told that light is wave, but Huygen told the light is wave. His theory was rejected, but after 200 years approximately, the Young performed the YDSC, Young double slit experiment, which shows that light is not particle, rather it is a wave. But in approximately initial of the 19th century, right, and the end of the 19th century, the photoelectric effect, right, was found, and which can be explained on the basis of the particle nature of light, right, with the help of the Max Planck quantum theory. You understand or not? Now the scientist was confused that whether the light is to be assumed to be wave or whether the light is assumed to be particle. In 1929, the de Broglie was the scientist. De Broglie was the scientist who told that this our nature is symmetric, right? Our nature is symmetric. If the light can behave as the particle, so therefore the particle can also behave as the light. He gives some experiment, right? He performed some experiment on the basis of fast moving particles like electron, proton, right? So fast moving particle, electron, proton, neutron can behave as the wave. All right. So he gave the de Broglie hypothesis that every particle which is moving very fast can behave as the wave. So therefore the particle and the wave, right, are very much similar. Sometime the particle can behave as the wave and sometime the wave can behave as the particle, right? So that is why this is called the dual nature of light. In some time the light can behave as a wave or light can be behave as a particle. You understand this? So this is the history of the light, but we are not going to discuss all this thing. We are discussing the Huygens principle or the Huygens wave theory, which was given during the time of the Newtons. Is it clear or not, you tell? According to the Huygens, little theory I will give you. According to Huygens, right, light is made of wavefront. Light is made of wavefront, right, and it propagate in the medium, right, in the form of wavefront, in the form of wavefront. Is it clear or not? Wavefront, in the form of wavefront, right. So first of all I will consider what is wavefront. What is wavefront, right? What is wavefront? It is the imaginary, right? It is the imaginary it is the imaginary surface upon which all particles are vibrating in same phase. All particles are vibrating in same phase, right? This is called the wavefront, right? What does it mean? Listen one thing. For example, if you consider the point source, right? The point source, if you consider, right? Point source you consider, right? So from the point source, the spherical wavefronts are produced, right? Spherical wavefronts are produced. You understand or not? If you consider the line source, this is the line source of the light, like tube light you can consider. This is the line source of the light. So from the line source of the light, this is the line source of the light. So with the help of this line source of the light, the cylindrical wavefront are produced, right? These are the spherical wavefront. All right, this is spherical wavefront. The another source is the plane source of light. This is what? Plane source of light. Plane source of light. With the help of the plane source of the light, the plane wavefront are produced, right? Suppose this is the plane source of light, right? The plane wavefronts are produced, and in the form of the these are called plane wavefront. So in our discussion, we are going to discuss, or we are going to explain each and everything in the form of the wavefront, right? What are the wavefront? If you consider the wavefront, all the particles present, these are the imaginary surfaces, and all the particles present are vibrating in the same phase. What does it mean? All the points present on this wavefront, this is the spherical wavefront, are in the same phase. What does it mean? I will explain this also. In the same way, suppose this is the cylindrical wavefront. So all particle present on this cylindrical wavefront, right? Like this, right? On this cylinder, they are vibrating in the same phase. In the same way, if it is the plane source of light, the plane wavefronts are produced and they are vibrating in the same phase. Is it clear or not, you tell? Yes. Copy this. So according to the Huygen's wave theory of light, all particles present on wavefront, right, act as a new source of light, and produced spherical wavefront in forward direction only, right? And these new source of light are called secondary wavelet, right? These are called secondary wavelet. Is it clear or not? Secondary wavelet. And the new position, right, and new position of wavefront, new position of new wavefront, right, is obtained by drawing the tangent, on by drawing the tangent on spherical wavefront, right? So this is the Huygens wave theory of light. So according to Huygens, light is wave and it propagates in the medium in the form of wavefront. But what is the wavefront? Wavefronts are the imaginary surface upon which all particles are vibrating in same phase, right? And all particles present on wavefront act as a new source of light, and these new source of light are called secondary wavelet, from which they produce the spherical wavefront in forward direction only, right? And the new position of the new wavefront is obtained by the tangent, right, by tangent on these spherical wavefront. Is it clear or not, you tell? Right. For example, suppose this is the point source, right? This is what? Point source of light. So from this source, the spherical wavefronts are producing, right? And according to Huygens, every point on this surface act as a new source of light, and which are called secondary wavelet. This is the point source, this is the new source of light, from which, from these secondary wavelet, what is produced? The spherical wavefront in forward direction. So this is the spherical wavefront, spherical wavefront, spherical wavefront, spherical wavefront, spherical wavefront, spherical, in forward direction, not in backward direction. And new position of the next new position of new wavefront is obtained by drawing the tangent upon this, right? So this is the new position of the wavefront. This is the initial wavefront and second wavefront. Again, every point on this wavefront act as a new source of light, and these new source of light are called secondary wavelet, from which the spherical wavefront in forward direction are obtained. Is it clear or not, you tell? And the new position of the next new wavefront is obtained by the drawing the tangent upon this. You understand this thing or not, you tell? Right. In the same way, if this is the point source, if you consider this the line source, right? So from line source, what type of the wavefront is originating? Right, it is the cylindrical wavefront. New source at every point on the cylindrical wavefront, this is the line source, right? This is the line source, and every point act as a new source of light, and from which the spherical wavefronts are obtained. Spherical wavefront, although this is the cylinder like this, right? Cylinder like this. So every point present on the lateral surface act as a new source of light. And how to find the new position? By drawing the tangent upon this, right? So it will be the new position of the wavefront. You understand or not? Right, copy this. So on the basis of the Huygens principle, right, they explain the phenomena of the refraction and the refraction, right? So explanation of refraction I will give first, right? Refraction, explanation of refraction with the help of Huygens principle. Suppose this is the medium, right? This is what the medium 1 and medium 2, right? Its refractive index is n1. So speed of light in this medium is what? v1 is equal to c upon n1. What is the speed of the light in the medium 2? Is equal to c upon n2. And what is n1 and n2? These are the refractive index, right? Refractive index of the medium 2. You understand or not? Right. So suppose this is the boundary, this is the medium 1, this is the medium 2, and the light is coming in the form of plane wavefront. Light is coming in the form of plane wavefront. Suppose this is the plane wavefront, right? And it is when this wavefront hits, tell me, suppose this is the plane wavefront, when it is coming, so every point on the wavefront act as a new source of light. The spherical wavefronts are drawn, and they drawing the tangent, this is the new position. So the plane wavefront is coming when it hits at this point, right? So every point act as a new source of light. Is it clear or not, you tell? Right. Yes. So as this is the distance, suppose, right? From here, what is obtained? The new wavefront is obtained, right? New it acts as a new source of light. This is the secondary wavelet, and the spherical wavefront is produced. Listen one thing, this also acts as a new source of light, and the spherical wavefront is produced. Are you getting or not? The spherical wavefront mean the sphere is being produced like this. Are you getting? So if in this time from these 2 points or these 2 sources are in the same phase, so if you consider this is the distance, if you consider this is the distance, so how to obtain the new position of the new position of the new wavefront by drawing the tangent upon this. So this is the right, this is what, this is the new position, and now the wavefront move like this. Is it clear or not? The wavefront move like this, the wavefront move like this. Is it clear or not? So if this is the angle of incident I, so if this is I, this is 90 minus I, so this angle is what? I. All right, this angle is supposed to be R, right? This angle is supposed to be R. This is 90 minus R, right? You may assume this is the R, right? This is 90 minus R and this is angle R. Are you getting or not? Yes. Like this. This angle is R. This is the incident wave, and after reflection it become like this. So if this is R, this is 90 degree, this is 90 minus R, and this angle is R. Is it clear or not? Yes. Right. If you consider this is the A, B, right? You consider this is the A, B or C. It is what C dash, suppose it is what D. Yes. Sin R. Tell me, what is sin R? Sin R is perpendicular, that is AD upon hypotenuse AC. Is it clear or not, you tell? Yes. In the same way, what is sin I? Please tell. Sin I is perpendicular BC upon hypotenuse AC. Is it clear or not, you tell? Yes. So from here the AC is equal to AD sin R. From here the AC is equal to AC is equal to AD upon sin R. From here the AC is equal to BC upon sin I. Fine. So if speed in this medium is V1 and speed in this medium is V2, in the time t, this wavefront travel this distance. Suppose this is the S1, and this wavefront travel the distance in the medium 2. Suppose this is the S2, right? So what is AD? AC and AC both are equal. So AD upon sin R must be equal to BC upon sin I. What is AD? AD is the distance is equal to S2 is equal to V2 into T. V2 the speed, and what is S1? BC is nothing but S1 is equal to V1T. All right. So sin I upon sin R, I am writing this side, implies that sin I upon sin R is equal to BC upon AD. BC is nothing but V1T and V2T. This distance is nothing but V1T and this distance is nothing but V2T. So it is V1 upon V2. From here sin I upon sin R is equal to what? V1 upon V2. What is the V1? Is the speed of the light in the medium 1, speed of the light in N2 upon N1, right? So sin I into N1 is equal to N2 into sin R is equal to constant. So this is called what? Snell's law, right? So the Huygens explain the Snell's law, right, in the form of, with the help of its wave theory, right? Huygens principle. Is it clear or not? Yes. So the refraction is explained on the basis of the wave theory also. Copy this. Now let us see the explanation of reflection. Reflection by Huygens principle, right? With the help of Huygens principle, you can write only this. Suppose this is the mirror and the plane source of the plane wavefront, the light in the form of the plane wavefront is coming like this, in the form of plane wavefront. When this wavefront is incident over this reflecting surface, right? Suppose the name of this plane wavefront is this, right? you may assume this is the AB. All right. So what will happen? It acts as a new source of light. So from here, the wavefront is obtained, like is spherical wavefront is achieved, right? It is propagating, and this light source moving in this way. Are you getting or not? From this, the wavefront is obtaining. So when this wavefront reach at this point, right? Suppose the time t, after the time t, it reaches at this point. So what is the distance? This is the medium. The same medium is this or not, you tell? So this distance is nothing but suppose v into t. So in the same time, the wave, this distance is also equal to the same distance vt. You understand? And the next position, new position of the new wavefront is obtained by the drawing the tangent upon this. So this is the new position of the wavefront, and then it move like this, right? So this is the position of the wavefront, then it start moving in this way. Is it clear or not? Right. Suppose this angle is r. This is the angle of refraction. This angle is what? This is the angle of incident, right? And after this, it moved to the r. All right. This is the angle of refraction. So it is 90 minus r, and this is r or not, you tell? Yes, it is correct. So you tell me, if this is I, this is 90 minus I, and this is equal to what? Say I. So in this triangle, if you consider A, suppose you may assume this is the AB, this is C and D. So now we have the two triangle. In triangle ACB, triangle ACB. The angle C is what? Say 90 degree. Are you getting? Angle C is what? 90 degree. And in triangle BADB. What is this? Angle D is what? Say 90 degree. Also, the two sides are equal. AC is equal to what? VT. And BD is equal to what? BD is also equal to VD. And BC is common. BC is common side, right? So if you consider the two triangle, right, angle, side and side, both are same, right? So this is these two triangles are, right, the similar triangle. Therefore, listen one thing, if this is angle I, this angle I, right, and this angle is what? Say R. Is it clear or not? So therefore, the angle I and angle R are also equal, right? Also equal, right? Because the triangle ACB is similar triangle with ADB. Both triangle are similar. So in this triangle, this angle is I, and in this triangle ACB, this angle is R. So one side, two sides are same, right? And one angle 90 degree is same. Side angle, side are same. So these two triangle are similar triangle, and therefore their other angle also be equal. So therefore the incident angle and reflecting angle are same, and this is called the law of reflection, right? So on the basis of the Huygen's principle, right, in the form of the wavefront, the reflection can also be explained. You understand? Copy this. Now we discuss the coherent source of light. Coherent source of light. Please tell me, what are the coherent source of light? The two source of light, if the phase difference between two sources of light is constant and does not change with time, right? Two sources are called, then two sources are called, two sources of light are called coherent sources. Coherent sources. Is it clear or not? Right. Listen one thing. This is the one point, this is the another point. If you take a two similar bulb, right? Two similar bulb of they are of, suppose they are producing the red color light. There is power is also same. They are similar two sources in every aspect. But these two sources, similar bulb, similar bulbs, right? Similar bulbs, right? In every way, right? In every way. But they cannot be coherent, right? They cannot be coherent. Is it clear or not? Why they cannot be coherent? Because when the light is producing, right? When the light is producing, the light is produced in the form of photons, suppose, right? And the phase difference between the phase difference between the two photons or the two light wave is not same, although these two bulbs are very much similar in everything. They cannot be, right, coherent, two sources of coherent. Are you getting or not? So for the two sources, right, there are some way, there are few methods by which the two coherent sources can be made, right? So we have to use some technique, some technique to produce uh, two coherent sources, two coherent sources. Are you getting or not?
Yes.
So there are two methods. Method 1 to produce the coherent sources is the wavefront division method. Wavefront division. The method 2, right, the wavefront division method and amplitude division method. Amplitude division method. Amplitude division method, right? So we have the two method we will use to produce the coherent sources of light. All, if you take the one bulb, another bulb, it can never be the two coherent sources. So produce the coherent sources, we will use some technique, and the two methods we will use, especially the wavefront division method and the amplitude division method. All right, copy this first. For that, we will discuss the interference. So before doing the interference, the principle of superposition, I think it is very common when in the class 11th, right? The principle of superposition of waves. In the class 11th, the same principle we have discussed many times, right? The superposition principle of wave. What is this principle? When two or more waves, when two or more waves, right, propagate in the medium, propagate in the medium. What are the waves? It may be the light wave, it may be the sound wave, it may be the wave in a string. The superposition principle is same for all. When two or more wave propagate in the medium, right, then at any point of the medium, any point of the medium, the resultant displacement, the resultant displacement displacement is the vector sum, is the vector sum of individual displacement produced by individual displacement of waves, right? Individual displacement of wave. What does it mean? If there are so many waves, this is the one wave, this is the two wave, this is the three wave, right? This is the one wave, this is the two wave, this is the three wave. Suppose when they propagate and they are reaching to this point, so the resultant displacement of this wave, suppose this is the y1, this is the y2, this is the y3, and this is the resultant wave displacement. So at any point in the medium, the resultant displacement is nothing but the vector sum of the individual displacement due to the wave. This is called the principle of superposition. Is it clear or not, you tell? The same principle of superposition we have used in the sound wave and the wave instinct also, right? Copy this. So now we will discuss the interference. Interference, right? Interference. What is interference? When two waves, right, two waves of same frequency, two waves of same frequency and coherent, when two coherent waves, you will write, when two coherent wave of same frequency propagate in the medium, in the same direction, right? When two wave, there are two sources of light, these two sources are coherent source and the frequency must be same, propagate in the same direction, then due to superposition of these wave, the intensity at some point, is more, and at some point intensity is less. Is it clear or not? Suppose there are two sources of light. Suppose this is the one source, this is the two source. The frequency must be the same, and they must be, the source S1 and S2 must be coherent. S1 and S2 say coherent. Is it clear or not? So when the light wave propagate, light wave in the form of the wavefront, suppose this is the spherical wavefront, right? So when they superimposed in the medium, at some point, suppose this is the point, this is the light is coming from here, the light is coming from here, also there may be the some point the light is reaching from the two source at this point, so in the medium, some point the intensity is more, intensity is less, somewhere the dark is obtained, somewhere the this is the dark, maximum light is obtained. Are you getting or not?
Yes.
Right. So this phenomena is called interference. What is interference? When the two coherent source produce the light or the wave and they propagate in the medium in the same direction, due to the superposition, some points in the medium have the maximum intensity and some point has the minimum intensity. Is it clear or not? And this is the distribution of the light or the intensity in the medium is not same. Sometimes, somewhere it is maximum, somewhere it is minimum, and this phenomena is called interference. You understand this thing or not, you tell? Where the intensity is maximum, right? The interference at that point is called constructive interference. Is it clear or not? and where the intensity is minimum, the interference is called destructive interference. Is it clear or not, you tell?
Yes.
So this is this is at this point the constructive interference, at this point the destructive interference. Is it clear? Copy this.
Yes.
So now this is the definition of the interference which we are going to discuss, the mathematical expression of the intensity or the interference we are going to discuss, right? Suppose this is the S1, right? It producing the light in the form of whether it is the spherical wavefront or the cylindrical wavefront, the light, its displacement is A1 sine omega t, and this is the source S2. S1 and S2 are coherent source, and its displacement or the light wave is nothing but omega t plus phi. What is its phase? Can you tell me? Say omega t. What is its phase? Say omega t plus phi. Can you tell me what is the phase difference? Phi 2 minus phi 1. Say phi. So it is constant or not? So if the phase difference between the two sources of light is same, is constant, does not change with time, so what type of source they are called?
Coherent source.
Coherent source. So these two sources are coherent, right? So now the resultant intensity, resultant wave according to superposition, therefore superposition principle. What is superposition principle? The resultant displacement is nothing but y1 plus y2.
Y.
What is y1? Say a1 sine omega t. What is y2? a2 sine omega t plus phi. Fine.
Yes.
So the resultant wave we are going to find a1, this is sine omega t, a2 sine a plus b, sine omega t into cos phi plus cos omega t into sine phi. a1 sine omega t plus a2 into cos phi into sine omega t, right? Plus a2 into sine phi into cos omega t. Is it clear or not?
Yes.
Now a1 plus a2 cos phi into sine omega t plus a2 sine phi into cos omega t. This is the resultant wave. This is what? AR cos alpha. If you assume this is what? AR sine alpha, then what will you get? AR sine omega t cos alpha plus AR cos omega t sine alpha. If you take AR common, you will get sine omega t into cos alpha plus cos omega t into sine alpha. This is the resultant wave. AR sine A cos B cos A sine B. What it is? Sine omega t plus alpha. So this is the resultant wave. What is it? This is the resultant wave, right? Copy this first. So this is the resultant wave due to the superposition of two coherent source of light, where what is AR sine alpha, you tell? AR sine alpha is what? A2 sine phi. And what is AR cos alpha, you tell? A1
A1 plus A2
cos phi. This is the equation number 1, equation number 2. Now
Yes.
1 square plus 2 square is equal to A square sine square alpha plus AR square cos square alpha is equal to what? A2 sine phi square, A1 plus A2 cos phi whole square. Is it clear or not?
Yes.
If you take the AR square sine square plus cos square alpha, A2 square, A1 square plus A2 square cos square phi plus 2A1 A2 cos phi. This is equal to 1. AR square is equal to, listen, this is the A1 square. If you take a2 square common, sin square phi plus cos square phi plus 2a1 a2 cos phi, it is again equal to 1. So the resultant amplitude is a1 square a2 square plus 2a1 a2 cos phi. Cos phi, phi is the phase difference between the two sources of light, right? So what is the AR? Square root of a1 square plus a2 square plus 2a1 a2 cos phi. This is what? Resultant amplitude. Is it clear or not?
Yes.
This is what? Resultant amplitude. But from the class 11th, the intensity, if you consider the intensity, right? If you remember, the intensity is proportional to amplitude square and the frequency square, if you remember, right? So, but here the intensity is proportional to amplitude square. If this is the source 1, this is the source 2, its intensity is I1 proportional to its amplitude square. Its intensity is what? I2 is proportional to A2 square. Is it fine or not? And the resultant, when the two waves are reaching some point, the resultant wave is obtained. So its intensity here is proportional to the resultant amplitude square. Is it clear or not, you tell? Hello?
Yes.
So the intensity I1 is proportional to A1 square, A2 square. Resultant intensity is, its amplitude is what? Resultant amplitude. Is it clear or not? So
Yes.
also you may write the A1 is proportional to root I1 and A2 is proportional to root I2. You understand or not?
Yes.
So from here, the AR square is what? Say IR. A1 square is what? Proportional to I1, I2 plus 2 root. What is A1 proportional to? Root I1, root I2 into cos phi. Phi is the phase difference. So this is the resultant intensity. What is it? Resultant intensity. Right? Copy this. So this is the resultant intensity. So when the two wave propagate in the medium due to the interference, as I told you, some point the intensity is less, some point the intensity is more. The phenomena is called the interference. Where the intensity is maximum, this is called the constructive interference. So what is the condition for constructive interference? For constructive interference, right? Tell me,
Yes.
the intensity is what? Say maximum.
Maximum.
Intensity depends upon what? Suppose this is the source S1, this is the source S2, its intensity is I1 and I2, and the phase difference between them is phi. So I1 and I2 cannot be changed, but if you choose the different position of the different points, suppose one wave is reaching from here, the other wave is reaching from here. In the same way, if you consider this the point, one wave is reaching from here, the another wave is reaching from here. So the intensity I1 and I2 will not change, rather the path traveled by the two waves at the different point in the medium will be the different. This is the path 1, path 2 at this point. This is the path 1, path 2 at this point. So for different point, different path traveled by the wave. So if the path difference is there, different, the phase difference will be there. For the different path, the phase difference can be changed, right? The phase difference can be changed, but it is constant. It is not variable. It is not varying with time. For example, here suppose the path difference is to be pi, right? 0, supposed to be 2 pi, 4 pi. So if it is here is 2 pi, it will remain always 2 pi. It is not changed. At this point, the phase difference may be suppose 3 pi. It is phase difference 3 pi. At different point, the phase difference may be different, but with time it is not changing. It will remain 2 pi always. Are you getting my point?
Yes, sir.
because they are already the coherent source. Their phase is not changing with time t. The phase difference is not changing time t. So for the constructive interference, the intensity is maximum. It will be maximum when cos phi value is maximum, right? What is plus 1? Sit cos 0, cos 2 pi, cos 4 pi, and so on. So you may write this the delta phi. Suppose in place of phi you may represent it by delta phi 0, 2 pi, 4 pi, 6 pi, or the phase difference in general point may be, general form may be equal to 2n pi. So the maximum intensity will be equal to what? I1 plus I2 plus 2 root I1 I2. So what is the maximum intensity formula? Say I1 plus I2 ka whole square. Is it clear or not, you tell?
Yes.
So this is the maximum intensity. Suppose there is a 2 pi, phase difference is over here. So what is it? It is the constructive interference over here, and the maximum intensity you are getting. Is it clear or not, you tell?
Yes.
In the some constructive interference, if you consider the amplitude, the cos phi is what? Say 1. If it is 1, so what is the maximum amplitude at the constructive interference? Root over a1 square, a2 square, 2a1 a2 cos 0, yeah, it is 1. So it is equal to what? A1 plus a2 whole square. So what is the maximum amplitude, you tell? A1 plus a2. Is it clear or not?
Yes.
This is the maximum amplitude. This is the maximum intensity. Where? At constructive interference. When the constructive interference occur, when the phase difference is in the form of 2 pi. Is it clear or not?
Yes.
We have also the relation delta phi is equal to 2 pi by lambda into delta x. What is delta x? Say path difference. Path difference. Suppose this is the path x1, this is the path x2. So what should be the path difference between the two waves at this point, so that the constructive interference, that is the maximum intensity, is obtained? Listen, delta phi when is 0, right? What should be the path difference value? Say 0, right? If the delta phi is supposed to be 2 pi, tell me, what should be the path difference value?
Lambda.
If the path difference supposed to be 4 pi, tell me, what is the value of delta x?
2 lambda.
It is 2 lambda. Is it clear or not, you tell?
Yes.
Getting?
Yes.
So if you take the general formula for the phase difference, if delta phi is what? 2n pi is equal to 2 pi by lambda into delta x. 2 pi will cancel out. Delta x upon lambda, delta x is equal to what? Say n lambda. So that is, if path difference at a given point, is either 0, lambda, 2 lambda, 3 lambda, or n lambda, then the interference is, please tell, say constructive interference, right? It is constructive interference, and the intensity is maximum root I1 plus root I2 whole square. Is it clear or not? So for constructive interference, what should be the path difference between the two wave reaching at a point, say in the form of n lambda, either 0, lambda, 2 lambda. For 0, the phase difference is what? 0. For lambda, right? What is the phase difference? Say 2 pi. For 2 lambda, 4 pi. For 3 lambda, 6 pi. For n lambda, 2n pi. 2n pi,
2n pi.
right? Copy this. Now this is the condition for the constructive interference. Now I will consider the condition for destructive interference. Destructive interference. All right. What is the condition of destructive interference? The resultant intensity should be minimum. Tell me, what is the resultant intensity? 2 root I1, root I2 cos phi. For the minimum intensity, what should be the value? It should be minimum. What is the, yes, the maximum value is +1, the minimum value is -1, and -1 cos phi occur at cos pi, cos 3 pi, cos 5 pi, and so on. So therefore the phase difference must be equal to pi, 3 pi, 5 pi, or in general you may write it is 2n minus 1 pi, right? 2n minus 1 pi, and may be written as 1, 2, 3, 4. Here if it is 2n pi, so n may be written as 0, 1, 2, 3 like that, right? And corresponding path difference you tell. Delta phi is equal to what? 2 pi by lambda into delta x, or you may write delta x is equal to delta phi upon 2 pi into lambda. So if delta phi is equal to pi, right? So what is the delta x you tell? Pi upon 2 pi into lambda is equal to what? Lambda by 2. If it is 3 pi, 2 pi into lambda is equal to 3 lambda by 2. 5 pi, 2 pi into 5 lambda by 2. Is it clear or not? So it means the phase difference must be, path difference must be equal to, for pi, lambda by 2, 3 lambda by 2, 5 lambda by 2, 2n plus 1, 2n minus 1 lambda by 2. Is it clear or not? So that it should be the path difference. It should be the path difference. Fine. Between the two wave. It should be the phase difference between the two wave reaching at a point. And what is the minimum intensity? Tell me. I1 plus I2 plus 2 root I1, I2 minus 1. It may be written as root I1 minus root I2 whole square. Is it clear or not? And what about the resultant amplitude was A1 square A2 square plus 2A1 A2 cos phi. So the minimum amplitude is root over A1 square minus A2, right? Because it is minus 1. Cos phi is what? Minus 1. So it may be written as a whole square. So it comes to be A1 minus A2. So this is the minimum amplitude, this is the minimum intensity. You understand or not? So sometimes they also ask the I max ratio to the I min. So this is root I1 plus root I2 whole square, root I1 minus root I2 whole square. This is the one ratio they will ask. They also ask the maximum amplitude to the minimum amplitude, A1 plus A2 and A1 minus A2. This is the magnitude I have taken because sometime the A2 may be greater than A1. So you will take the magnitude. You can write, or in some book it is written as A1 plus A2 magnitude of A1 minus A2, right? So this is the two ratio they will ask. So this is the constructive and destructive interference conditions, right? Copy this. So read this question. In this question, the two wave represented by y1 is equal to 4 sin omega t and y2 is equal to 3 sin omega t plus phi pi by 3, right? Interfere at point. Suppose these are the two waves. They are moving. So its amplitude is what? Say 4. its amplitude is what? Say 3. They interfere at this point. So the resultant amplitude you have to find. So what is the formula for the resultant amplitude? You tell. A1 is square, A2 is square, 2A1, A2 cos phi. Phi is what? Pi by 3. So what is the A1? Say 4 and it is 3. 4 is square plus 3 is square. 2 into 4 into 3. Cos 60 degree. It is 1 by 2. It is root 16. 9 plus 12. 25 और 12 कितने हो गए? Root 37. Right, root 37 is approximately 36. So you can write the resultant amplitude is approximately 6. Fine. Copy this. So read this question. There are two beams of light. Suppose this is the one beam, this is the another beam. Is it clear or not? So they interfere at a point. This is the point A. Here the light rays is moving, the light rays is reaching from here. This is the another point B. From here the light ray is reaching in this way, the light ray is reaching in this way. So its intensity is what? Say I. Its intensity is what? Say 4I. Is it clear or not, you tell? So at point A, what is the phase difference is given? Say pi by 2. At point B, what is the phase difference is given? Say 2 pi. Is it clear or not? So what is the resultant intensity at A? Tell me. For this is I1, this is I2. So I1 plus I2 plus 2 root I1, I2 cos. What is the phase difference over here? Sometime it is represented by cos phi or sometime it is represented by delta phi. There is no big difference. So here the delta phi is what? Pi by 2. Tell me. What is cos pi by 2? Say cos 90, which is 0. So the resultant intensity is I plus 4I plus 0. So it is what? Say 5I. Is it clear or not, you tell? If you consider the B, at B is equal to what? Say I1 plus I2 plus 2, right? I1 plus I2 plus 2 root I1, I2 cos. What is the phase difference at point B? Cos 2 pi is nothing but cos 360 degree. And it is equal to 1, you will remember. I1 is I, 4I, 2 root I, root 4I, right? It is into 1. So it is 5I plus 2 to the 4I. It is equal to what? Say 9I. This is the resultant intensity at B. This is A and this is B. What they are asking? The difference. So what is the difference between A and B? Difference between resultant intensity and B and D is equal to what? Tell me. 9I minus 5I is equal to 4I. So 4I is the correct answer. Copy this. So read this question. In this question, in an interference pattern, the slit width are in the ratio of, right, 1:9. Suppose it is W1, it is width 2. So W1 upon W2, the width ratio is 1:9. Is it clear or not? Find out their maximum ratio of minimum to the maximum intensity. When you will place the screen over here, due to the interference, the intensity variation on the screen will be there, and somewhere the maximum, somewhere it is the minimum. So they are asking the minimum and maximum intensity ratio. So I1 minus I2 whole square root I1 plus root I2 whole square. Is it clear or not, you tell? This is the thing. Now tell me, this is the width, right? Width ratio, the intensity at the source of width W1 is I1. Here the intensity is I2. Here the amplitude is A1 and amplitude is what? Say A2. Are you getting or not, you tell? Right. So the intensity W1 and W2 width is proportional to what? You tell me. intensity ratio, right? Also, if they ask the amplitude, so A1 square upon A2 square. So what is the I1 and I2 ratio? Please tell. Same as the width ratio, 1:9, right? So tell me, I2 upon I1, you may write 9:1 or not, you tell. So if you divide by I2, if you divide by I1 in the numerator and denominator, so would you get this or not, you tell?
Yes, sir.
If you divide in the numerator and denominator by root I1, so you will get this ratio or not, you tell?
Yes.
So this is equal to 1 minus I2 upon I1 is what? Say 9. Say 9. 1 minus 3 upon 1 plus 3 whole square is equal to what? Say 2 upon 4 whole square is equal to what? 1:4. Is it clear or not, you tell?
Yes, sir.
So the Imin to the Imax, the ratio is coming 1:4, right? Copy this.
Yes.
So read this question. In this question, the intensity variation in the interference pattern. What is the interference? Somewhere the intensity is maximum, somewhere the intensity is minimum when the two sources I1 and I2 propagate in the medium, right? The intensity variation in the interference pattern obtained with the help of the two coherent source is 5%. 5% mean 5% of the average intensity. Suppose the average intensity is 100, you may assume. So the maximum intensity is varied by 5%. It means 100 plus 5. So the intensity become 105, right? And the minimum intensity is varied by 5% to the average intensity, it become 95. So, and they are asking what? I1 upon I2 ratio they are asking. So Imax upon Imin ratio is nothing but root I1 plus root I2 upon root I1 minus root I2 whole square. Is it clear or not, you tell?
Yes.
So maximum is what? Maximum is 105. It is 95, right? If you divide by I1 plus, if you give the divide by the I2 and root I2 in numerator and denominator, right? You will get this thing, right? 21 or it is 19. So 21 upon 19 is equal to root I1 root I2 plus 1 root I1 minus 1 whole square. Is it clear or not, you tell?
Yes, sir.
Now you will simplify and you will get the answer, right? You have to simplify this. How to simplify, please tell. It is square root of 21 upon 19 root I1 upon I2 plus 1 root I1 upon I2 minus 1. When you will simplify, you will get it is 1.05, right? So 1.05 root I1 upon root I2, 1.05 is equal to root I1 root I2 plus 1. So when it is subtracted, it is 0.5, right? Is equal to 1 plus, it is 2.05. So root I1 upon I2 is equal to what? 2.05 upon 0.05. It is 5. It is 41, right?
Yes.
5 चौक 20 5, right? I1 upon I2 whole square 41 square, right? So what is 41 square? Tell me. 41 into 41, 4 चौक 16, 81. So it is 1681, right? Approximately. This is the ratio. Copy this. So read this question. In this question, consider the interference between the two intensities. S1 intensity is I, S2 intensity is what? 4i obtain intensity at a point where suppose the two waves are reaching at this point, right? So the phase difference is what? Say pi by 2. So resultant intensity you have to find I1, I2, 2I1, 2 root I1, root I2. Is it clear? Into cos delta phi. I1 is I, 4I plus 2 root I, 4I into cos pi by 2. What is cos pi by 2? 0. So what is the resultant intensity at this point? Say 5I. Copy this.
Yes.
So read this question. The two current sources I1 and I2 ratio is given 81/1. Produce interference fringes. Calculate the ratio of maximum to the minimum. So what is the maximum to the minimum? Root I1 root I2 upon root I1 plus minus root I2 whole square. So if you divide by root I2 numerator and denominator, would you get this thing or not, you tell?
Yes, sir.
This thing, right? And the square. So root I1 I2 was 81. So root 81 is what? Say 9. Say 9 plus 1 upon 9 minus 1 whole square. It is 10 upon 8 whole square. It is 5 upon 4 whole square. It is 25 upon 16. I max to the I min 25 upon 16. Is it clear? Copy this. So read this question, very much similar it is. Consider the interference between the two sources S1 and S2. The intensity is I and it is 4I. Right. So A part, you have to find the resultant intensity when the phase difference is what? Say pi by 4. So resultant intensity is nothing but I1, I2, 2 root I1, I2, and this is what? Cos pi by 4. Is it clear or not, you tell?
Yes, sir.
So it is I plus 4I plus 2 root I root 4I into 1 by root 2 cos pi by 4. It is 5I, it plus 4I by root 2. So it is 5I plus 2 root 2I. So if 5 plus 2 root 2I is the resultant intensity when phase difference is what? Say pi by 4. In the B part, what if delta phi is what? Pi. So resultant intensity is what? Say I1, I2, 2 root I1, I2 cos pi. What is the value of cos pi? Say minus 1. I plus 4I plus 2 root I, 4I minus 1. It is 5I minus 4I because 2 root I and root I become equal to what? Say I, right? And 2 to the 4. So it comes to be I. So this is the resultant intensity, I, right? And what is the C part? Please tell. In the C part,
Pi by 4 pi for 4 pi.
it is 4 pi.
Yes.
So resultant intensity is what? I plus 4I plus 2 root I root 4I, and what is it? Cos 4 pi.
Minus 1.
Now cos, it is 4 pi or not?
Yes, sir.
Cos phi is 1. Cos 4 pi, cos 0, cos 2 pi, cos 4 pi, cos 6 pi, it is equal to what? Say 1. And cos pi, cos 3 pi, cos 5 pi, it is equal to what? Minus 1.
Minus 1.
So I plus I, 5I, it is equal to 4I, and it is plus 1. The intensity resultant is maximum, it is equal to 9I. Right? Copy this.